To understand this, we can understand this from vector algebra very easily as to why this should be the case. Because suppose VR is the velocity of the river with respect to ground, and Vm is the velocity of the man with respect to river. Because what would happen when we swim, the mechanical motion of our hand on our limbs are such that we are moving perpendicular to the river. At any stage, if a man is here and he's moving his hand and legs in such a way that he is keeping perpendicular to the flow of the river, he's always moving his hand, the river is flowing in this direction, he's moving his hands and limbs perpendicular to the flow of the river. So he will move perpendicular, he's trying to move perpendicular to the flow of the river. So the velocity the man is generating by the motion of his hand and limbs will be perpendicular to the flow of the river. But there will be some velocity of the river in this direction, and the man will try and generate velocity perpendicular to the flow of the river. So that velocity I am calling as Vm. This Vm is the velocity of man with respect to river. That is, in any direction the man intends to keep the velocity, it is that velocity with respect to the river. So if the man wants to move in this direction, he will align his hand and limbs in this direction, and then with the movement of his hand and his limbs he will flow in this direction. So this velocity is the velocity of the man with respect to river. So that velocity I am calling as Vm. Okay, now the velocity of man with respect to river is velocity of man minus velocity of river. This is how we write relative velocity, right? Velocity of A with respect to B is velocity of A minus velocity of B. This is velocity of man with respect to river is velocity of man, velocity of man, which is with respect to ground. So I may write it as Vmg, velocity of man with respect to ground, which is the actual velocity of man, minus velocity of river. Okay, so velocity of man with respect to ground is actually velocity of man with respect to river plus velocity of river. So this is the velocity which the swimmer generates due to the mechanical motion of his body. Velocity of man with respect to river, that is the velocity the swimmer generates, and this is the velocity of river. So velocity of man with respect to ground, somebody looking from the ground, for him the swimmer is moving with velocity Vm vector plus Vr vector. Now if the man intends to go straight perpendicular to the flow of river, just opposite on the other side, then the velocity that the man would be generating, that would be Vm, and the direction will be perpendicular. But the velocity that it will get eventually, and the velocity of the swimmer with respect to an observer on ground, that means velocity of the man, the swimmer, with respect to ground will be velocity of the man, which the swimmer is thinking that the velocity he is generating. That velocity plus the velocity of river, that is the actual velocity of the swimmer. And this is the velocity of man with respect to river plus velocity of river. The summation of these two would be something like this. That's why the man will move in this direction, even though he intends to move perpendicular to the river, but he will end up moving at some angle with respect to vertical. So that's why there will be some drift, and he will never end up in the point just opposite on the other side. Okay, so this is from the vector algebra, that the velocity of the man ultimately would be the velocity of the man with respect to river plus the velocity of river. Okay, now let's suppose this distance is d, velocity of river is VR vector. Velocity of man with respect to river is VM vector. Now let's try and think of a situation when the man crosses the river with shortest distance.